All right, we might as well go ahead and get started with this video today. I thank you for checking out the stream, checking out the video. If you like what you see on YouTube, definitely please like and subscribe. It definitely goes a long way to help out and encourage, shows a little bit of encouragement for me to continue going on with these series and going down this path. So we ended the last stream where we just started uh, fleshing out the stepper motor, the driver schematic capture, getting the IC in here, so we can start doing all the plumbing and wiring it in. So to save a little bit of time, not much, I went ahead and downloaded the footprint, the symbol, uh, and started getting KiCad set up with all that. I want to go ahead and kind of rearrange some of these pins as usual, just to make it a little bit easier for schematics and for human readability to understand what's going on. So, like all the grounds, I'm gonna put together. These guys down here, I'll probably end up changing a few. Okay, so let's get this guy moved out of the way. Get a no connect down here. Just okay. So the biggest thing I want to do is be mindful of these guys. I mean, it really doesn't matter because they're pretty clearly defined. We'll want to make sure we uh, run them appropriately to the um, connector we want to do on the schematic itself. Uh, Mainly that way we have a straight shot from the IC to the plug-in, the pluggable, the connector, uh, without having to use vias. That way, we have a straight, clear path because of the potential current we're pushing through. It's just a lot cleaner, a lot neater. We can handle everything with labels on the PCB and clear, concise directions on how to wire all this up. So that's one thing to be mindful of. We can group it all together here just as long as it's plumbed together properly in the actual PCB layout. And we'll make sure we follow all that so there's no crossovers. We'll think it through and fix things before we put things hard to stone. Because typically, um, you'll have your inputs over here, your outputs over here, inputs on the left, outputs on the right. Uh, Not all these are um, controlled through a microcontroller. Some of them are actually set up based off of like reference voltages and other functions. So basically, take from their typical application off the um, data sheet. This is what they've set this particular chip up to operate a stepper motor, and they find that it works just fine. The biggest thing to watch is right here is this big electrolytic capacitor here. This is the voltage coming into the motors that acts as a big bulk capacitor. Um, Without that, you will fry this chip as it tries to drive the current to the stepper motors. That just acts as a big buffer to help feed the system while it runs through its steps. So that is definitely a must. Like I said, otherwise this chip will toast it. 100 microfarad minimum. Uh, Recommend maybe going a little bit over it, maybe 200 microfarad, 150, somewhere around there. We'll see what's available as far as parts. The next thing to really look for is the current sense, 200 milliohms. So it's basically like 0.2 ohms. Make sure we're kind of duplicating the circuit. So one of the things we're going to want to do is kind of make sure we have things laid out here to make it a little bit easier to do that. So we're kind of dragging this stuff around to make it a little bit easier to have this to schematically plumb it all together. Okay, AV ref, BV ref, the voltage refs. So they'll get tied together to the same voltage divider. So we'll kind of, since that's a reference, maybe we can throw it over here. These are inputs, your micro stepping inputs. Drag these guys kind of out of the way for now. And in the schematic, we'll kind of throw in a little logic chart to show basically what your highs and lows are on each mode, what it'll do. Maybe we can set a default mode with pull up or pull down resistors, even though we're going to be tied to. I mean, it doesn't really matter because uh, we can have the default on this guy is to be disabled. That way, it won't do anything, and that's the enable right here. So here are your motor outputs. We'll put them on the other side. Again, I like doing this just for readability, to understand what's going on with the system. So these will go to the sensors, the current sense resistors. This is going to be for a voltage divider. Okay, VMA, VMB. That is the power supply for the motors themselves. VCP will feed off of that. So VMA, VMB, and VCP will be tied closely together. CPP 1 and 2, they just get tied together with an external 10 nanofarad capacitor. So let's see here. Let's move this guy out of the way. Let's move this guy, even though in here it doesn't really matter. This is for my sake. So that's an input. That's an active low input for home. See, that's a step input. So since these guys are kind of not really inputs, they're just functional. Let's drive it there. We could technically put these guys on the other side. I'm not going to worry about that right now. Depends on how everything's going to look. V3 out. Let's look what that guy does. Okay. Looks like it's just an output, but it, even though it doesn't really go anywhere. Okay, V3, 3.3 volt output. I don't think that can source a whole lot of current. So I'm not going to worry about tying that into anything, but the data sheet does say, because I've used this chip before, to at least have that coupled to ground with the capacitor. Okay, these are outputs. Let's see, the end fault is an output. Keep that on this side with the motors. This is an input. An input. Again, we might be fixing out that decay is an input. Well, it's not really an input. Decay. You set that typically. Where do you set it at? Decay. You pull it high or low. Come on, get to the pin out. Decay. All right. Decay mode. Slow decay, fast decay. It's got an own internal open. If you leave it open, it's mixed decay. So I'm going to look at my past design. I left it open. It doesn't hurt it, but you typically pull it up or down, or basically leave it alone. And that's what I'm going to do. So decay. It's technically an input. So the cool thing about this particular driver chip is it actually gets its own internal power supply for operation through the motor voltage input, and it has its own internal regulator. That's why you can get 3v3 out. I'm gonna put you down here. No big deal. Direction, that is an input. Enable, that's an input. Fault is an output. So that would be going to the microcontroller. All right. AL1. AL2. BL2. And BL1. All right. And we'll figure out all our orientations and stuff. We'll plumb it all together, but we may have to kind of fix schematically how we want to do it. VCP. That's right. That. Let's go back down to the typical application. Double check. Okay, that just gets tied there, coupled with a capacitor and a 1 mega ohm resistor. So we'll kind of drag you up a little bit. Not the cleanest. All right, so we have our modes. Okay. Enable. Reset. Sleep. Home. Put you down here. That's your direction. Clockwise, counterclockwise, basically. All right. Not as clean as it could be. Move these guys down a little bit. That way, kind of open this up a little bit. Not like it really matters. Pretty much all our input control side. Technically, that would be an input, the current sense. So we'll leave that be. And at the end of the day, we'll see how it looks schematic wise. We can always fix it. It's not set in stone. Not going to hurt anything. So this is going to be our essential fixture here. Let's go ahead and put you over here because you're going to plug in here. Now we might have to let's see here, because remember, uh, those pins, the output are on the um, left hand side of the chip, and then they're just kind of represented on the right hand side here, so things are going to get flipped. So what we're going to do is we're going to flip this along the y-axis by hitting the Y key to basically put pin 1 at the bottom. That way when it gets interpolated over to the PCB, we'll just kind of keep that there. We'll plumb it all together once we get the other schematic components put in. So I've already got this, used this chip, and I'm just going to reference an existing schematic to a project I've already been using it in. That way it's just a little faster. I don't have to keep flipping to the data sheet. But for all practical purposes, we're mimicking this, their typical application circuit. Usually, if you follow the manufacturer's typical application circuit as closely as possible, and then when it comes to PCB time, do the best to follow their layout example. I mean, as best as possible. You won't have too many problems. Looks like they're pulling from here with vias, which we can. We can go from top to bottom layer with heavy traces to as long as we have at least 2 or more powerful vias tying them together. That's what that's representing, because we have to deal with the current sensor resistors. So let's make sure. Let's see if it gives any recommendations on, because a lot of times you'll get recommendations in here for like bulk capacitance. You'll have recommendations for everything else. Let's see if they give recommendations for like the current sensor resistors. And I don't think they do. Let's see here. Okay. Let's see. Okay, to achieve IFS equals 1.25 amp. So we're definitely going to want a decent size current sensor resistor. And if you go by the layout here, that's a pretty good size current sensor resistor right there. They're probably looking at 805, somewhere around an 0805 package, based off of how many pins that's encroaching. It's covering like 3 pins. So we'll at least start with an 0805. Sometimes if we go here, let's go here. So Texas Instruments is one of those. Okay, so So sometimes they'll have a let's just see, I don't want Sometimes I have a dev kit or a dev board. Let's see. Sometimes I'll actually offer a development kit around that particular chip, and their dev boards will have. Yeah, I don't think they have it. I don't think they have a development board. Like a yeah. We'll have a schematic, and if they, they'll have a dev board, they'll have the schematic and a bill of materials. So a lot of times you can uh, basically just mimic what they used. So, but like I said, based off of the layout and the we're probably looking at least an 0805. So we're gonna make sure we select those. So let's grab some of our capacitors and other parts that we know we're going to need. All right, so we already have our 24 volts, our ground. Let's go ahead and based off of that, let's grab. Let's see here. 100 nanofarads. Two there. That's not. Three of them. I don't think we have. Yeah, there's a lot of parts we don't have yet, like resistors. 30K, 50K. 30 ohms. Yeah. Yeah. We don't have. Yeah, there's quite a few parts we don't have. A couple of resistors, some capacitors, the current sense resistors. So let's methodically add what we need. So the biggest thing is the the big bulk electrolytic capacitor. So let's grab that guy. Oh, capacitors. Now we could use a tantalum, but they're more expensive. And price versus a capacitance, especially only 100 microfarads, it's fine. We'll just go with an aluminum electrolytic. So we'll go with the, let's see here, aluminum organic polymer. So voltage is a big concern. So we're at least 24 volts. So let's go with a 63 volt, 100 microfarad. T. How many are for the 10,000 an hour? Huh. Just out of curiosity. Just seeing what kind of price we're looking at. Not too bad actually. And Nichicon is a good company. Good product. But I'm worried about that stock. So let's get rid of that 10,000 an hour. 6,000 an hour. We won't worry about it. Alright. Yeah, stock is going to be a big concern. Other projects I've worked on, uh, electrolytic capacitor stock has been kind of like the bane of those projects. Chemet is a good product. 8,000 in stock. Chemet. Price isn't too terribly bad. That's not bad at all. Yeah, mainly I'm kind of like looking at this, what's immediately in stock. I mean, the price isn't too terribly bad. $1.49 either. It's $1.32, but the stock is always concerning to me. Okay, that's rated as a long life capacitor. It's automotive rated. That might actually be a winner right there. Stock's pretty good. Price isn't extremely high. 22 weeks. Now, just for grins, let's see if DigiKey has it. Okay, they have them in stock as well. Again, like I said, electrolytic capacitors have been kind of the bane of projects. So there's 3 vendors right here with a pretty decent quantity in stock of that capacitor. So yeah, let's go ahead and use it. That's one thing you want to at least try to source a minimum of 2 vendors, 3 if possible. But we'll stick with the with just Mauser for now. Got the symbol, the footprint. All right, extract all. And as usual, some more of the same. The KiCad and the footprint. Import that footprint. Move you out of the way. I don't know if it'll matter. Now, let's see here. Now, typically with capacitors, all right, a lot of times their height and diameter, well, mainly the diameter, will set the footprint size. So a lot of times you can find a drop-in part that meets the exact same specs, has the exact same footprint. Uh, so let's see what it wants to save the footprint as. So it wants to save it as that component instead of like a industry standard, like for the 0603, 0805. So a lot of times when I do an electrolytic capacitor, I will just say the footprint as that part number. That way there's no confusion down the road. It does happen to where there won't be any drop-in capacitors. So just to be mindful of that. Sometimes you can find one that'll fit. May not be a perfect fit. Oh gosh, I love this. Nope. Wrong direction. So was that the right way? Yes. Yeah. Ah, don't do that to me. Come back here. Let's open you back up. Okay. Oh, I keep hitting enter. Oh, I don't like doing that. All right. All right. Let's. Okay. Don't need to be perfect, but like that. So one of the things I do want to point out, well, no, this might not be a perfect representation, but yeah, one of the things I do want to note is how they indicate the positive and negative parts to the can, to the capacitor. Positive is this side, the long line, because you'll see it kind of the capacitor outline here. So even though that is what they use to designate, I like to avoid confusion and just throw in a plus symbol. Let's go see how it looks on the 3D view. Let's just take another good look. I like to do that just as a clear indicator of what's supposed to be where. Let's see, what size are we? Gotta make sure it'll be legible. All right, let's just give it a good view here. We can make it a little bit bigger. Let's go 2.54. Nah, that's a little too ugly. All right. See what that looks like. Let's see. Yeah, there we go. That's perfect. Okay, let's go to our symbols, our components. Now we don't have an electrolytic capacitor symbol in here yet, which will be helpful once we get this in here. KiCad. All right, boom, 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 boom. That's fine. So we're gonna EC for see capacitor E. So CE for capacitor electrolytic. And then if it was tantalum, it'd be CT capacitor tantalum. That'll be the part number. For properties. Ah. All right. Only because I like the way this is all organized. And val. So it's 100 UF. No. 63 volts. Don't need that. Make sure we have the right footprint. Okay. Low volume. $1.49. And the closest is $4.72. $1.49 and 472. All right, now and then it is an organic polymer. Organic polymer. 100 UF, 63 volts. I keep pushing the wrong buttons. Oh, 63 volts. Dun, 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 dun. 4,000 hour life, not too bad. ESR, 18 milliohm ESR, might be important. 10 millimeter diameter. 12.2 height. Height on some parts does become relevant at some point, especially if you have a pick and place machine. Uh, you need to know that for some parts. For all the parts, their height. It's just so the machine knows, how far down into the pocket to grab, how far down before it actually places onto the board. A lot of pick and place machines have a height limit on components, so this is definitely good to know. Negative 55, 125. Oh. It's Rojas. And it's ACQ200, right? Yep, ACQ200. That means it's an automotive standard part. So that is good to know. All right, bump, 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 bump. Everything's here. So, you know the drill by now. We're going to throw this guy into Odo. Malza. Let me just go here and grab it. $1.49. That's capacitor. Grab this so they match. Control C. Boom. Back to here. Okay. Save that. Just in case I need to refresh. Capacitor electrolytic. Oh, why it keeps telling me footprint not found. Boom. So that is for the later part. So these guys come in off of the VNA and VNB. Let's get this ground out of the way. Nope. Ugh. Boom, 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 boom. Get you guys in here. All right. Stop acting like that. goofy little thing. All right. So kind of pull you down. It really doesn't matter because I'll move that guy kind of to match. All right. Well, you're annoying. There. That guy. All right. So now let's do this guy. Okay. So now we have our voltage input for the motors. Now we have. So we have this guy. All right. So this guy. Okay, so now based off of the circuit, we're going to need a 1 mega ohm resistor. So let's go select that guy, passive components. Yeah, it's right. You know what? Let's just go back to your passive components. Resist alls. SMB chip resistors. That could be an 0805 or 0603 because it's such a first of all mega ohms. 603, and it's used for a reference. Okay, so it's an 0603, 1 mega ohm resistor. So we've already got the footprint, not worried about that. ROM, not bad stock, but you know, the Vichet is pretty good stock. 10,000 in stock, but your MOQ minimum order quantity is 10,000 on that. All right, so Wilson, no, never heard of them. Not worried about that. Let's see what we got up here. I mean, that stock's pretty good. That stock's pretty good. 24 cents, 13 cents on a ROM. Stock's not too terribly bad. I mean, it's right now we're only using one, but I think we're just gonna go with the Vichet. A little bit more expensive, but I'm more comfortable with that stock quantity. It's 1 mega ohm. 210 milliwatts. But here it's only 125 milliwatts. Very confusing. Very confusing. Since there's no 603, I'll just go ahead and count it as the 100 milliwatts. I'm not going to sit here and argue over that. I'd rather be underrated than overrated. So we're going to go to just 0603. We're going to duplicate that. Now, So the resistance is 1 meg. So for the part in here, rename. Okay. 10K2, 603. 1 meg 0. What's your voltage? Alright, doing the wrong thing again. What's your voltage? 75 volts. And we're just still going to count it at that. Properties. OV. 1 megohm. What's your tolerance? 0.1%. 55, 175. You're not Q200. 175. Damn. You're not AC. You're not automotive rated, but that's fine. All right. All right. Let's do Vichet. Mauser part number 24 cents. There, I keep going. Wrong button. 1,139. And it's a 1 megohm. And you guessed it. If you said we have to put it in Odo, you would be correct. Stars. But again, we are slowly building up a library to where we can eventually stop adding stuff as often. All right. So now we've got that in there. Megohm, pump, 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 pump. Go back to our schematic. Let's go and throw that guy in there. Our CO603, 1 megohm. So, some semblance of similarity to the capacitors. No big deal. So, schematically, let's make some more room. Because we can always adjust stuff later. So these guys pull off of basically the same voltage. And then VCP ties into that network right there. So now we have our voltage, our motor voltage input, and the that reference voltage. I can't remember exactly what function that's for. VCP. I think it's a voltage reference. The datasheet should outline that, but not terribly a major concern right now. So, other components we might want to grab real quick. Actually, we can do the 10 nanofarad capacitor. Let's go and grab that real quick. Capacitors, LCC, multi-layer ceramic capacitor. We're going to go with 0603. 50 volts. Apply, and it is a 10 nanofarad. Or 0.01 microfarad. All right. Oh, here we go. 0.01. Here we go, right here. There's plenty in stock of this guy at only 10 cents. And it's a Murata, so we're just going to go that direction. All right. 103, so let's go here. Components. 0603, we're going to copy that. We're going to duplicate the symbol. We're going to rename the symbol. And what's funny is 103, not 104. Our voltage should be 50 volts, and I gotta remember for capacitor tolerance, it is 10%, and AAA, and the dielectric is X7R. X7R. File properties. And 0.01 microfarad. So 55, 125. 55, 125. REQ 200 part, just making sure. Yep, AECQ to 100. Some customers that matters. It's a Murata. Mausa, their part number. 10 cents and 019. 9. And it's just 01. Boom, 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 boom. Okay. Here we go. Fun stuff again. This eventually gets so common, it all becomes yeah, 10 cents, general information. Category capacitors. Reference from KaiCan. That way we match everything. Update that. Okay. Save that. Add our new 103. That is off of the CP1 to 2. Which is fine if we just kind of tuck you right here. Don't have to drag any of that around. Bam. All right. There we go. So now we might as well go grab our current sense resistors. Like I said, so let's go back to here. Hello. Hey. Chip resistors. Like I said, I think that's an 0805. 5. 200 milliohms. Perfect, perfect, perfect. 74 cents, 63 cents, 17 cents. Not bad for a Vichet. What's their stock? 32,000. That's not bad at all. Not bad at all. Like, is it stock and stock is the big thing to worry about. Yeah, 32,000. That's not too terribly bad. That looks to be a good one to grab. And it's a quarter watt. That's even better. All right. So that's an 0805 package. So here we go. Our favorite thing to do. Do I have a chip resistor? 805. We're going to duplicate it. We're going to rename it. 805. So what we're going to do, 805, 0R2, and then our voltage is, tell me I missed you somewhere. No, you don't have the voltage on here. Let's go. It's safe to assume 75 volts, 50 volts. Okay. What is and it says a quarter watt, and I don't think we have one for quarter watt. $200 milliwatts, so AE. That properties. .2 ohms. What is your tolerance? 1%. Temperature range 55, 155. Your Q to 100. All right. So, Vichet. Mouse pot. 17 cents and 0.51. All right. And 0.2 ohms. All right. Our next favorite thing to do, throw an Odo. So we don't have to worry about it later. My memory is just horrible. 17 cents. Boom. There we go. Got it in there. Let's make sure we're saved here. Okay, all that should change. Save that. Back to the schematic. Back to here. So it's 0805 0R2. So that is purely for the current sense. Just slap you in there, slap you there. So we got our current sense resistors in there. Okay, so okay, bump, 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 bump. So we've got most of this wired in, most of this plumbed in. Let's just go ahead and plumb you together. Okay, so we got you plumbed together. There's no connect. 3v3 out. And this is where it's going to get interesting. So, okay, let's see where we're going here. Yeah, I should have fixed the symbol a little bit. AV ref, VV ref. Okay. So, maybe I'll fix the symbol a little bit, update this, put these two near this guy, clean these guys up a little bit, not move anything else. And then we can finish plumbing this guy together. And in the next video, there's a lot to cover. A lot more still to, few more things still to go. We're getting much closer to reaching the end of this part, the schematic capture. We'll see. I think the stepper. Then we got to throw in the fan, which we might throw it on the stepper driver circuit on this schematic, because technically it's going to be to actively help cool this chip. Once we get that, we should be almost done. Wow, getting close, getting real close. Yeah, not a whole lot to do, because if we go here, we've got that plumbed in. We've got our inputs. We're getting that done. We've got our power supplies done. Yeah, the big thing, we got that to finish up and that to add, um, and then that'll be it. Wow. All right. So I'm going to end the video and the stream here. I thank you for watching, and check out the other videos in this series. This will be uploaded on YouTube. Um, on Fridays, I'll get this series uploaded. Like I said, give me a bunch of them in advance to help fill in that gap while I wait on parts to arrive to actually build it when we get to that phase. Have a good evening.